this is Travis the Tau Templar. Welcome to my full mining course. We are going to learn how to mine Tau from the very beginning to the very end, from picking a subnet to mining on it. I highly suggest you listen to this introduction, as I can guarantee that 90% of you will decide not to try mining once you've heard how difficult and different it is from regular crypto mining. Not necessarily technically difficult, but very, very competitive. If you're looking for a regular Bitcoin mining course, I'm sorry to be the one that breaks it to you, but you're never going to have that sort of simple buy hardware, plug in electricity, and wait sort of mining. Mining has become a full-time job, and you'll need to be monitoring your miner for problems and constantly look for ways to increase your profits so that you can remain competitive. Miners compete in a free market. Mining Bittensor is very, very hard. Many of us think that mining is as simple as hooking up a GPU to the network and leaving it run for months without any maintenance. This is not possible in Bittensor. At this point, you'll need to be a developer with some decent knowledge, because the competition on Bittensor isn't ever going to die down. If you're someone who is looking for a set it and forget it type of mining, as is typical in crypto, Bittensor mining is not for you. Sorry, it's just not. However, if you're an AI researcher and you don't really know anything about crypto or Bittensor, then this course is made for you. If you're just learning about how to run Linux commands and you want to get a clearer idea of how to run servers, then this course again is made for you. Each subnet can have approximately 256 participants, most of which are miners and some validators. So let's just say for simplicity, each subnet has 200 slots for miners. This means that out of the entire world, there are only 200 slots to mine in the subnet. So you're competing against the top 200 people in the world at completing that subnet's task. And if you're a really good miner, sometimes you'll purchase more than one slot. So really, you might only be competing against the top 50. As more people learn about Bittensor and put in the time to learn how to mine, it becomes more and more difficult to mine. So competition on Bittensor increases over time. This means there is no better day than today to start, because tomorrow there will be more competition. So if you're not daunted, start today, immediately. If you are daunted, and that's fine, because you can contribute to the network by bidding up the price of Tau. And if you really want to go hard and you don't have enough technical experience to mine, you might consider being a professional staker. Picking the winning subnets will likely be a full-time job that positively contributes to the space. Understand that you will very likely fail to mine on the very first subnet you mine on. You'll likely run into a bunch of issues, and then you'll learn from those issues and then try again on another subnet, becoming wiser and more capable with each attempt. So as for the requirements, if you have a PC, you'll want to install WSL. If you're on Mac or Linux, you already have a terminal window, so that's not applicable to you. You want to have some basic crypto knowledge. You don't have to be super knowledgeable about crypto. I do share a lot in the course. The part about how I secure my wallets, I think, is particularly valuable for newbies, even non-miners. You will need some Tau to pay the registration fee for your miner. And you will very likely lose your registration fee on the first couple of subnets that you try mining on. Just be aware of this. And it's nice if you do have some basic Linux knowledge about basic Linux commands, but it's not necessarily required. I tried to accommodate for people with limited Linux knowledge in the course. It might be helpful to watch some of my other videos on how Bittensor works first before you look at mining, just to give you a general idea as to how Bittensor works in the first place. I think my videos are probably the quickest way to get up to speed on how the network works. All right, let's go over some caveats of the course. Remember that with mining Bittensor, you actually have to provide value to the network to be rewarded. So no one is going to make a course that will teach you how to mine and be profitable on day one. This is simply because they'd be teaching you how to compete with them, and nobody does that. Again, no one is going to tell you how to profitably mine. This course is to teach you how to mine, not how to profitably mine. The course is not perfect. The original plan was to make a really polished course and be updating and improving it on a regular basis, and I've since decided that I won't be spending my time on that. And I just wanted to get this out so that at least it's providing value to those interested in mining. Also, this course was made before the dynamic TAO network upgrade, so some of the BTCLI command output might be slightly different than when you run the commands. Instead of miners directly receiving TAO, you'll be mining subnet tokens, which you can then exchange for TAO. Mining hasn't really changed otherwise. I encourage you to look at the comments of this video on YouTube. I'll be marking the comments that I find helpful or that have corrections to try to keep this video from going out of date too quickly. My donation wallet is in the description of the YouTube video on my TAO Templar YouTube channel. Please don't feel obliged to donate. This was recorded a few months ago and a lot has changed. I think there's probably better websites out there for Subnet Research than the ones I used. Don't mine on the subnet that I chose unless you've got knowledge of that subnet's theme. It is now too hard to mine on that subnet as a newbie. The course doesn't go into how to optimize your miner, which is really the most important part for profitability, and it's also not something that you can put into a video because it'll be unique to each subnet. And even if someone did tell you how to optimize your miner publicly, it's now public knowledge and it's no longer going to give you an edge. The course doesn't teach you anything about how to fine-tune or train AIs. For subnets that do those sorts of tasks, you'll want to study those topics more. I had originally separated everything into many videos, so you'll hear me referencing other videos in this one. Just be aware that there are no other how to mine videos at this time. I've just stuck them all into this one video. I am not an expert miner, but I can show you how it's done. So looking back on the course after a few months, there's many things that I'd improve about my process. When I finally got to mining on the mainnet, I had everything set up completely and correctly, but I found that I couldn't be competitive on the subnet I chose. And so therefore I couldn't receive any emissions despite being set up correctly. I had hoped to show some profit in my wallet in the end, but the reality is that I had recorded and edited for many, many hours by the time I realized I wasn't going to be competitive in the subnet, and I'm not going to re-record everything and try again. Regardless, this course encapsulates everything that you'll need to know in order to become a miner. That said, there's a lot you could improve upon in this course. This course is just an introduction. If I could go back and re-record it, I would have improved the way I did logging, monitoring. I might have changed cloud providers. I would have certainly upgraded BTCLI earlier, opened my ports much earlier. I would have definitely checked Discord more thoroughly. A seasoned miner won't get much out of this course. This is for beginners who want to hit the ground running by learning a process that actually gets a miner off the ground. It's not a motorcycle, it's a pedal bike. At the very least, you'll learn how to set up a miner fully and with all the steps involved. This course doesn't teach you how to become a profitable or successful miner. It only teaches you the steps involved to get a miner running on the mainnet. I even left in some of the pain points that I overcame and some that I didn't overcome, just so that you know that everyone goes through pain setting up their first miner. So we're just going to go over a quick overview of the steps that we take to become a miner on the mainnet. And then we'll follow these steps after we've gone through them. So number one, you want to get familiar with the Bittensor Discord. You can't get very far mining Bittensor without being on Discord, or at least a little bit. Number two, if you're on Linux or Mac, you can skip this step as you probably already have a terminal installed. If you're on a PC, you'll need to install WSL, Windows Subsystem for Linux. Number three, you need to install BTCLI and get familiar with some of the commands. Using BTCLI, you'll be able to see a lot of the statistics that you normally use something like TAO stats for. Number 4, Subnet Research. There's a lot I could talk about here, and there's like a full hour on this in the course. And I feel like I've learned a lot since making the course even. But in the course, at least we look at some of the considerations for picking a subnet. Specifically, we look at emissions, registration costs, the docs and repository for the subnet. Does it have a testnet? Is the subnet owner or team active? Do they have a roadmap, etc.? What is the miner key distribution, the profitability? In the course, we answer these questions for 3 separate subnets that piqued my interest, and then I picked the one that I thought had the best chance of success. As you start to mine and gain more experience, you're probably going to add more requirements or more attributes that you're looking for in the subnets that you mine, but this is a good starter list. Number 5, you're going to follow the subnet's documentation for how to set up your miner. Each subnet is different. This will not be the same between each subnet. This is the hardest part, I think. You'll run into driver issues, port issues, maybe even space issues and random subnet bugs that Google can't even help with, etc. Then we're going to set up a miner to run locally on our computer. And then we're going to rent a cloud miner and point it at the testnet. And then finally, we're going to take that cloud miner and point it at the mainnet to actually receive rewards. Number 6, we're going to consider improving our subnet's default miner code. Number 7, look at cheaper cloud providers. This is soon going to get weird and crazy as Bittensor is fast becoming the best source for cheaper cloud providers. A bit of inception there. And then 8, you're going to want to build out some monitoring to confirm that you're getting incentive and that your miner hasn't crashed. I hope you find some value in my experience. This has taken me over 100 hours of editing, and I was originally planning to make this a paid course. Was probably going to charge around $1,000. However, I've decided to make it free for various reasons that we can talk about another time, as this video is quite long already. Also, just wanted to mention in the description of this video, there are timestamps to the various parts of the video. I think it's helpful because the course is very information dense. So following this as a guide, let's jump right in to the miner course. Enjoy. So the first thing you want to do is download Discord and register for an account. Once you've done that, you can join the Bittensor Discord here. There's actually 2 Discords. There's like the main developer Discord and then the community Discord. The main distinction between these 2 is that in the developer Discord, at least that's what I'll call it, the developer Discord, there's no price talk here. So if you want to do that, you can go to the community. There's the discussion here is generally about the price or who to stake with, that sort of thing. But we're going to be a miner, so we're going to spend most of our time in here. Just a quick run through the moderators here. Like, we're in crypto here, so be careful. If somebody messages you, be very careful who it is. You got to confirm who it is. Nobody's going to ask you for your keys, all that junk, right? In the community here, we've got the general chat. You can ask general questions here. Then there's a help forum as well. You can ask some questions in here. Then we've got all of our subnets on the left here. So from 1 down to 52 currently. We've got 2, I guess, tabs for them here, 2, whatever you call these. And then we've got some testnets here. Not all of the subnets have testnets, but we're going to be looking at these. And then other languages, and then some OpenTensor stuff. OpenTensor is like the foundation. So we're not going to be paying too much attention to these or the other languages unless that's your thing. You can ask questions in the general chat, general questions. If you've got a question specific to the subnet that you're mining on, then you're going to want to do that in whichever subnet channel that you're mining in. Let's just look at a random subnet here, so subnet 19. If we go up here to the pinned messages, this is the location where you're going to find the GitHub, or the location where we're going to clone the miner code. This is where they do it. They put a message in here, they pin it, And then that becomes the place that you clone your repository from. We'll get into that in a bit. That's the general overview of the Bittensor Discord. We're going to go over some considerations for picking a subnet. These are in no particular order. First, let's talk about emissions. Emissions is the percentage of the TAO mined on the network that will go to a particular subnet, and therefore the miners on that subnet, i.e. you. Emissions on subnets vary depending on stakers. The subnets with higher emissions have higher competition, which means higher rewards. Since we're still learning, we're going to intentionally pick a subnet with low emissions so that we don't have to compete with these hardcore miners who are experts already. Also, higher emissions are usually correlated with higher registration fees, which is the second criteria I have here. We'll come back to how to calculate emissions and how to look at that. We'll go into more detail on how to actually look at each of these in the next video. Each subnet has a registration cost. It is the cost of registering for a slot on the subnet. It's the cost to kick out the lowest performing miner and take their slot. You do not get it back when you are kicked out. It is, quote, recycled. You can ignore recycling. What we really care about here is registration cost. For our first subnet, we're not going to want to spend a lot of TAO registering. The first subnet we choose is unlikely to be the one that we specialize in, so let's just build up some experience with a low registration cost subnet. So we're going to want to look at the documentation and the repository. This will give us an idea of the level of support we can expect from the subnet owner. Ideal documentation contains everything you need to get started. The reality is that no subnet owner will do this perfectly. We're going to look for end-to-end instructions on how to build a miner. We're also going to keep an eye out for special things required for our subnet. Sometimes you have to sign up or even pay for other services to allow your miner to compete effectively. This is our first miner setup, so we're going to read the documentation and we're going to watch out for whether the subnet requires us to pay more or extra than just the registration cost. While we're talking about the documentation and repository, I'll just talk about Docker here briefly. In theory, subnets that use Docker images will be easier to set up. If you don't know what Docker is, in short, Docker puts all the code, including the operating system, into an image. Then that image will work on any machine. You're not going to have setup issues like missing packages or random errors while you're trying to install the miner on a computer. So Docker usually means it's good. I say usually here because if you want to customize your miner, it could be more difficult to customize. You'll have to understand how Docker works to customize your miner and create a new image to run your miner. In the long term, it's probably worth learning about Docker, but we're going to try to find a subnet that doesn't have a Docker image so that we can go through as much pain as possible for your benefit in this course. We also want to check how frequently the repository is updated. If it's not being updated frequently, it's not a good sign. We'll have to check with Discord to see if the subnet owner has mentioned anything or if they're actually inactive and therefore their subnet is risking lower emissions. If a subnet owner becomes inactive, the emissions going to that subnet will be reduced by stakers, and therefore miners' emissions will also go down. So we're looking for an active subnet. Not all subnets have testnets. If your subnet has a testnet, that's really awesome. It lets you test things out before even paying the registration cost. For our first miner, we really want to be looking for a subnet that has a testnet so that we can play around and get comfortable before paying that registration fee and starting to mine. We're also going to be looking to see if the team is active. I mentioned this before with the repository. This is not necessarily required for your first miner setup, but it's really nice if a subnet has a roadmap. If they've got future plans, that ensures their future success. So if they have a roadmap, that's a good sign. How frequently is the subnet updated? Having to update your miner can be annoying, though it's usually painless. I get nervous when there's very few updates, though. because again, it's a sign that the subnet owner has possibly stopped maintaining their subnet, which affects the subnet's success. We're also going to look at the key distribution. This is a way to tell how many miner keys an individual is mining on. So you as a miner can have multiple keys within the subnet. If there's a whole bunch of those keys monopolized to one person, it could be a good or a bad thing. I'd be leaning towards bad, especially if you're new, because that means that one miner is doing most of the work on that subnet. So it'll be very hard to compete because they're probably really good. Although it could also mean that there's nobody who has tried competing with them. So we call these UIDs. There's 256 per subnet. Some of those are going to be validators, with the majority being miners, usually at least 200 are miners. There's definitely going to be a couple miners on the subnet that have many UIDs, and that's very normal. We just don't want to see one with too many. We'll take a look at that in the next video. And the last one we're going to look at is the scoring rules. So this is how your miner is evaluated. If you can figure out how to game these rules or improve your miner's output for these rules, those are ways you can optimize your miner. Probably not going to be doing that as part of your first miner, but maybe we'll have to look in the code for them specifically, because the code between each subnet is very different. So there's not like a perfect place to find it in every subnet, but I'll show you the tricks that I use to find the rules. You should see all of these as like a double-edged sword. So there's a positive side to each of these, no matter which way they swing. So for emissions, a subnet with a huge amount of emissions is going to be able to reward its miners a lot, which is great. But a subnet with low emissions is not going to be able to reward its miners as highly. But there's also less competition on those subnets with less emissions, and you can use that to your advantage. Registration costs, same thing. A high registration cost keeps out a lot of competition. A low registration cost is nice because you can get in easily, but there'll be a lot more competition. So we're going to be looking for good documentation, good repository, a testnet, active team. We're looking for all these things. But there's a flip side to these as well. If you can find a subnet that is not very well maintained, very difficult to get into, you're going to have less competition, and therefore the chances that you can profit from it are higher. So yeah, we're going to take a look at all these in the next video and try to get our bearings and pick a subnet. Okay, so let's start going through. We're going to pick the top 3 that are interesting to us and don't sound too intimidating. And then we're going to fill out some more information about each of the 3 subnets, 1, 2, 3. And then we'll compare them at the end and determine which one we think is our best bet as far as profitability and actually making it to the end as a miner on the mainnet. Okay, so on TAO stats here, if you click on subnets, click on home, you can scroll down, and each of these rows here is a subnet. You can order it by emission. So we're going to do descending. So if we look at the number of subnets total, we've got 52. With a bit of math, we can see that around 2% per subnet is the average right now. It could be different when you're watching. Maybe there'll be hundreds of subnets. So since we're new, we're going to be looking for emissions that are less than 2%, because the ones with more than 2% are going to have a lot of competition. Really, we should be maybe looking for the median, not just the average. But as a general ballpark, something less than 2%, probably closer to 1% is the area that I'm looking. If you scroll too far down, you're going to see that these ones here with 0% emissions, this guy in specifically, is in the danger zone, meaning that they're going to get kicked off the network the next time a subnet is registered. That's important for you to be aware of as a miner, because you don't want to be mining on one of these lower subnets because they're going to get kicked off soon. How soon, you ask? Well, if we scroll up here, we can look at the subnet registration cost graph here. Each time the price of subnet registration jumps, that means some miner or some subnet owner has registered a new subnet. So there's a jump here, jump here, jump here. Each of these jumps is a new subnet coming in and an old subnet getting replaced, getting rotated out. This will be different when dynamic TAO comes out, but right now there's no dynamic TAO. I assume when dynamic TAO comes out, you will not get kicked off. You just have lower emissions. So then you don't have to look at this graph anymore. But right now, let's just take a look at between the 24th of September and 24th of October to get a feel for how quickly subnet is rotated out. So we've got 1 registration, 2, 3, 4, 5, 6, 7, 8-ish, 8 or 9 registrations in a month. So that's once in every 3 days, a new subnet comes in and replaces one of the lowest subnets. So if you scroll down to the bottom here again, you probably, with that in mind, you're just thinking about how quickly a subnet could be rotated out. So this is like a month's worth of subnets getting rotated out. Now, if your subnet is updated frequently and stuff, it's never going to end up at the bottom here if it's actually valuable. So, but just for our first subnet, we don't want to pick anything too low, even though there's not much competition on these ones, just because we don't want to get rotated out while we're still figuring things out. So we're going to go for at least 0.5, 0.4, something like that. So really, I want to be looking in this kind of 1% range. I want you to be aware that there's many websites out there. You could probably Google and find more by the time you're watching this video. Everything updates so fast, right? So there's TAO Market Cap. I think this one is run by Datura. So very similar to TAO Stats, different interface. Maybe there's more information here. I haven't looked at it too much, but you can, go and see your list of subnets. Then there's app.access.dev. They've got their own way to evaluate subnets. We don't care about that. We just care about the root emissions. I was looking at the root emissions on here earlier, and they're not quite matching what it says on TAO Stats. So we're just going to want to confirm the emissions after using this website. And then there's TensorPlex here, has something similar where it says, the subnet and then a description about it. But right now, my favorite is this Access Dev one because it just makes it really easy to click on a subnet here based on emissions. So if we sort by root emissions, now I can just look at the ones in the range that I'm looking for. So for instance, graphite, I was looking at this one, a decentralized network for solving graph optimization problems built on Bittensor foremost, blah, blah, blah. So you can click here, it'll open up the repo. There's a warning here saying, hey, it's still being updated. There might be breaking stuff. And I'm like that should just be on every subnet. And then we scroll down here. We've got a table of contents. What is graphite? Specialized handling graphical problems. Okay. Focuses on the traveling salesman problem. The traveling salesman problem is a basic programming problem. So it looks like they're just focusing on this one problem. And then we've got algorithm support here. So instead of throwing our miners to fend for themselves, we provide 4 different algorithms to assist them in solving the traveling salesman problem. We've added these so it's not too daunting to begin mining on graphite. That sounds good to me. And then we can even read about the reward mechanism here. Yeah, so it's just returning high quality solutions within a time frame with some more details about the heuristic, blah, blah, blah. And then there's installation details here, basic installation, miner installation guide. Great. So this one looks good at a glance. So I'm going to write it down as our potential subnet to mine on. So this is subnet 43, it said here. So we're just going to write 43 in here. All right, let's move on. Let's find our 3 subnets. So that's 1 down. Other one I was looking at was, score predict here. Score Predict is, so it says Score Predict is a Bittensor subnet designed to incentivize accurate football, soccer match predictions. So let's open up their GitHub here. Ooh, there's a testnet. Tells us a testnet is there right away. This is nice. Talks about the leagues that you have to give predictions for. They've developed a front-end app which acts as another miner, collecting predictions from fans using intuition rather than machine learning. Users can sign up and make their predictions in the upcoming games. The consensus predictions for each match become the submissions for its single miner. Okay, so it's almost like the miner, their one miner is a subnet within a subnet almost. They're like they've got a consensus of predictions that the single miner gives. TAO rewards are earned by the miner and will be distributed to the end users. Okay, so this is interesting. So if you were not taking this miner course, this might be a good first foray into being a miner. So it does all of this stuff. So like for somebody with no technical knowledge, they could go in, they could make predictions, and then they would get TAO rewards through a website, not having to worry about any commands or anything like that. But that's just one of the miners. So this is like a convenience miner that they set up for their subnet. We can still compete as a regular miner. We don't have to use their app. Although maybe that would be helpful for us in trying to figure things out, being able to like look at how that app works. It's got a command here to quickly start a miner, it says. So that's nice. And then a manual installation thing. Great. That's what we're looking for. Just, yeah, this shows me that at least there's a path forward on this subnet. So that's great. Oh, it even has some scoring stuff here. You get some multipliers based on the length of your streak. That's interesting. There could be some like gamifying you could do with that. Maybe you have multiple miners that have different predictions in such a way that some of them can always get a streak. I don't know. They've made a decision to initially centralize the API, which can be used to fetch matches and results. This is to reduce friction for our validators. In the future, we'd like to decentralize this. Okay, so this sort of centralization thing, just as a kind of tip, generally the OpenTensor Foundation does not like centralized subnets. So they're not going to give weight to subnets that are centralized. So the emissions you're getting are going to be reduced in a subnet like this. And that's fine. We looked at what it is here is 0.38, at least through access. So this is the ballpark that we want, but the reason why it's low, one of the reasons is probably the OpenTensor Foundation is not giving it any weight because of this centralized aspect. All right, so yeah, this one looks interesting too. So let's add it. So we're adding 44 Score Predict as another potential subnet. All right, let's find the last subnet. I just noticed this here. You can click on this like review, I think. Yeah, it like gives you more information. So somebody has actually, I believe a human in this case, has actually like reviewed the subnet and given their opinions. So I don't see how validators themselves could get value from this directly. Of course, this could provide a massive positive influence on Bittensor, but I think this is missing now. So like these are all new subnets. This is going to be very common criticism. But anyway, so that's interesting because it gives you, again, a little bit more of an idea as to what you're mining on and if there's a roadmap and all that stuff. OpenKaido is an AI committed to democratizing access to Web3 information through its established platform. However, the in-house approach to blah, blah, blah burdens and stiffer. So again, that's another criticism that this website has of the subnet. Human scoring and decentralized image generation on Bittensor. Interesting. Human guided AI at the heart. By incorporating human. Okay, this is not giving me as much information as I was hoping. Visit our GitHub to explore the code. Isn't this our GitHub? Or are you talking about like neurons? Okay, so you're just, okay, that's just the code here. Join our Tensor Alchemy Discord. Okay. There's a miner guide, validator guide. This isn't giving me as much information as I kind of wanted here. Maybe do a bit more clicking before moving on. Oh, there's a testnet. That's good. That's good. Guide for miners. Okay, this is what we wanted. Great. Okay. Nice. Okay. So I'm going to add that. I hope that'll be the one because that just looks interesting to me. Okay. So now we've got 43, 44, and 26. These are the subnets that I've selected as things that are interesting to me that land within the emissions range that we're looking for. So we're not looking at like the super close to being deregistered subnets, but we're also not looking at the super competitive subnets. We're looking at the subnets with kind of low emissions where hopefully there's less competition and we can actually get some of the mining emissions.
So before we start mining on the mainnet and getting real TAO, we're going to test against the test network first. Depending on the subnet, you can probably just use your home computer for this. So you're going to get your miner running on your home PC and connect it to the testnet. That'll be step 1. Step 2 will be finding the cloud machine that you're going to rent and point that at the testnet. Of course, renting this cloud machine is going to cost you some money. That's step 2. And then, of course, the final step is to keep that setup that you have on the cloud machine and instead just point it at the main network for step 3. This is just good procedure. Step 1 costs you no money to try. Step 2 only costs you the cloud machine. And then step 3 costs you the cloud machine plus the registration fee to the mainnet. There's just a lot of things that could come up at each stage. Maybe you don't even get past number 1 because you find out there's something on the subnet that you don't like. And that way you don't have to kick yourself because you've already rented a cloud machine or something if you're still on step 1. And then maybe at step 2, you realize that the cloud machine that you rented isn't powerful enough. Whereas if you were to just go straight from mining your PC to the mainnet, you're going to make no money that way. You're going to have wasted your registration fee. So we're just going to follow these steps, 1, 2, 3. In classical development, you might call this testing locally as number 1. Number 2 might be QA or dev environment. And then number 3 is production. Okay, we're setting up the BTCLI Bittensor client. You're going to want to go to docs.bittensor.com and maybe just search here for install BTCLI. The instructions for installing this might be different by the time you're watching it, but you'll want to just follow along with what it says here. You can see here that I tried running BTCLI -- version. This will just tell us whether it's installed or not and what version it is. It was not found. It tells us to run this one. I wouldn't trust that. I think that's probably a different BTCLI, like Bitcoin client or something like that. So we're going to take this first command here. It's python-m venv BTCLI venv. Venv stands for virtual environment. That's the way that Python uses to segregate its versions so that the various programs that need different versions of Python don't have any conflicts. So we're setting up a virtual environment for the BTCLI. We'll copy and paste that in here. Now if we want, we can go into that directory, take a look. Not much to see there. Let's go back. And now we're going to activate that virtual environment. You can tell that it's activated because it has this BTCLI VN within parentheses here before the rest of your command line. If you want to deactivate it, you can just write deactivate. And to reactivate it, just source the same path again. So now we're going to clone the Bittensor CLI repository. So I'm just going to copy this command. And now in here, I like to keep my Git repositories organized. So I've got a folder called Git, so cd Git. But for you, you might make a new one, make dir, mkdir Git. For me, it says it already exists. But so now we're going to go into it. If I do an ls-lrt, it'll list out all the folders and files within this folder. You can see I don't have it yet, so I'm just going to paste in that git clone. And now if I do an ls-lrt, we can see that we have indeed cloned the BTCLI repository. Tells us to go in there and then do a pip install dot. Okay, that took a few minutes, and I believe that's it. So now let's just verify the version again. Perfect, it exists. Let's try running a command, BTCLI subnets list. And there we go, there's our list of subnets with the emissions. We'll be using BTCLI extensively, so it's very important that you do get this installed.
So we've now decided to start mining on Subnet 26, Tensor Alchemy. I'll just move this up to the top. The first thing that I want to accomplish is getting some Testnet TAO so I can start playing around with things and build up my confidence. To do that, we're going to have to go into the Discord and ask for it. We wrote down our Testnet UID earlier, so we're going to use this in our request for Testnet TAO. But first, we need to set up a wallet. So we're going to set up a testnet wallet here. To view the existing wallets that you may already have, you can do BTCLI W list for wallet list. You can see I have one wallet here. So we're going to add another wallet here for the testnet. So I'm going to run BTCLI wallet, or just W, create -- wallet.name, and I'm going to just name it something descriptive for myself for later on. So testnet UID 25. The reason why I said 25 there is because we have a testnet of 25 for Tensor Alchemy, which is Mainnet 26, but testnet 25. So I'm just going to put that here. The path to the wallets directory can stay the same. The new hotkey can just be default for now. You can choose any number of words here. The more words, the more secure. I'm just going to pick 12. Now it's going to ask you for your password. So you can see here that it generated a cold key and a hot key. These are two separate wallets, but they are connected. The cold key is like a regular crypto wallet. It's not like a cold storage wallet because you are going to be sending transactions from it. This is like your main wallet address. The hot key is going to be associated with the subnet that you're mining on. What we're going to do is we're going to pay the registration fee using our cold key. And when we are registering, we're going to tell it to register our hot key onto that subnet. And then at that point, that hot key is going to be associated with that subnet. And then we can get mining rewards. There's some good stuff in the Bittensor docs about hot and cold keys. The main things that we're just going to be using them for is your cold key here, which is more secure, and you can have multiple hotkeys associated with that one cold key. And to be fair, I'm probably only still going to use one hotkey per one cold key. I just think it's a bit safer that way to have separate cold keys if you're mining in multiple places. That said, if you have dozens of miners running, maybe it makes more sense to have multiple hotkeys for one cold key, but we're not anywhere near that right now. We're still learning. And then if we scroll down here, number 5 and 7, this is kind of a visualization of how registering happens. So we send TAO from our cold key, and that associates our hot key with the UID. And then once that association is live, then you can start getting TAO emissions to your hotkey and then send those emissions back to the cold key and then maybe to another wallet. So I'm just going to go over how I store these keys in a robust way so that I feel confident that if there's any issues, I can still recover my key. So I'm going to take the cold key here that I can see on my screen, and I'm going to copy that down onto one piece of paper here. Okay, so now that I've written that cold key down from my computer screen to the piece of paper, I'm now no longer looking at my computer screen, and I'm going to copy this piece of paper onto another piece of paper. So I've got copy 1, copy 2. This one was written down using the screen. This second one is going to be written down only using this piece of paper. So now I've copied this key onto my second piece of paper. So I've got a copy of it, and now I'm going to take this second piece of paper and I'm going to now visually check that all of these words match what is on my screen. So now I've checked, I'm reasonably confident now that both copies are the same. And now I'm just going to run through the exact same process for the hotkey. If we do BTCLI wlist, we can now see that we have a cold key with an associated hotkey. But we want to be extra sure that we wrote down these words properly. Maybe not for the testnet, but for sure for the mainnet. So first thing we're going to do is we're going to go to this wallet directory. Change directory to the wallet directory. Oh, I'm already in it. If we do an ls-lrt, we can see the wallet that we just made. If we cd into it, we can see it's got our cold key public.txt and then our cold key here. It also has our hotkeys, so we can cd in there. And we can see just the default hotkey. Okay, so we're going to go up 2 directories. So we're back to this main wallets directory now, and we're going to delete this folder here, which is essentially the wallet from your computer. So rm-rf space the folder name. And now we can see that the folder is gone. If we do BTCLI wlist, we can see the wallet is also disappeared from the client because I think it just looks in this directory. So we've got this BTCLI wallet regen underscore cold key with the wallet name. We're just going to call it the same wallet as before. You can add your mnemonic as part of the command here, but I don't like doing that because that can log it to various parts of your system. I'll just show you what I mean here. Some of this might be saved in your .bash history. So if we look at my bash history here, you can see these are the commands that we just ran. So they're being logged. You don't have to look in your bash history. I'm just showing you why I would never put my mnemonic into a command. So instead of using that parameter, we're just going to run it without mnemonic. Same path. So now we can take what we've written on our pieces of paper and write that in and generate the wallet from our pieces of paper so that we know that we can recover at a later date if we need to. So now we've recreated the cold key. So now we want to regenerate the hotkey. Pasting this in from the docs gives us BTCLI wallet regen underscore hotkey this time with a wallet name. Needs to be the same wallet name as the cold key. And then the hotkey wallet name, we'll just leave it as default. And again, the mnemonic, I don't want to write that in here. We'll just wait to type it in when it asks us. So now I've typed in my mnemonic from the paper into the computer again for the hotkey this time. And now we can see the cold key is associated to the hotkey just like it was at the beginning. And now we've confirmed that our backups work. So now we're going to get some Testnet TAO. To do that, you want to open your Discord. And in this help forum here, you're going to search for requests for Testnet TAO, something like that. I think it's the only one that's pinned here, along with many messages and likes. There's some other requests in here that just that aren't the same thing. So you want to find this pinned thread. Once you've found that, if you click open in full view, then it'll open like a sub tab underneath here, and you can look at the pinned messages and see what the requirements are for requesting Testnet TAO. It's actually really easy. Many other people do it, so you can just follow their template, or the best is to go into the pinned messages here and then read the most recent 1 or 2 messages. And they've got a template here for how to request Testnet TAO. So we're just going to copy this just to give you an example of how this currently works. If they give you an X, that means they've denied your request. The only reason I've seen it denied is if you're not doing it in the format they expect. So this guy didn't get approved because he didn't put it in the right format. The format they requested was like this. See, these guys also have checks. So we're just going to add our reason here. I want to mine on Tensor Alchemy. So we're going to take this testnet UID of 25 here. Copy that in. Mainnet UID if applicable. I'm not sure it matters. Haven't had to fill this one out before. But sure, we'll put it there. Roles, miner, cold key. We're going to take that cold key that we just set up and paste it in there. Do you have your mnemonics phrase for the cold key written down in a safe place? Yes, we do. And that's it. I've sent the message. So if it's your first time dealing with Testnet TAO, you're going to have to go through this. Once you have it, you can use your Testnet TAO just like you would on the mainnet and transfer it between wallets, whatever you want. So really you only have to go through this process once. They're probably going to give you a fraction of a TAO, but there's like no fees on the testnet. So that fraction of a TAO will go quite far.
I'm back about a day later and I can see that they have approved my request. So now let's check the balance in my wallet. So BTCLI wallet list, and then BTCLI wallet balance. And we'll just put in this testnet UID. See, I made a mistake here. I have it pointing at the Fini network, so that is the mainnet. So of course I have 0 balance on the mainnet. Let's change that to point at the testnet. So that's BTCLI W balance. Then we're going to add our subtensor network test. That'll point us at the right place here, and then we'll just do this for convenience. Wallet name testnet UID 25. And we can see that they have given us 0.1 TAO. That'll be way more than enough. So I have a little bit less than 0.1 now because I already sent a transaction. So let's just remember we started with 0.099. And we're going to do a test transaction to another wallet to confirm how transferring TAO between wallets works using BTCLI. So we'll do again BTCLI wallet create, and then we'll just keep everything as the default. So even the name of the wallet will be default, and its hotkey wallet will be default. Okay, so let's just check that we can see it using BTCLI. There's the testnet UID 25 that we made earlier. And here's the default cold key wallet we just made along with its hotkey default wallet. And then we're going to use BTCLI wallet transfer on the testnet with the destination of the cold key address that we want here. So I'm going to copy that in. Paste it in there. The amount, just make it very small, 0.001. And then the wallet that we are sending from, its name. So the wallet name of our test UID 25. And then hit enter. So we can see it's on the test network. That's good. And we'll agree to the fee. It says it's finalized. So let's again just look at the balance on our Testnet UID25 wallet. So as it says here, the balance has indeed gone down. And now let's look at the recipient wallet. And there's our very small balance of 0.00001. So the way that you're going to send TAO on the mainnet is going to be almost exactly the same. You're going to have a command just like this. And you're just going to get rid of this subtensor network test. You could probably just put in subtensor network fini, but that's the default. So we can just get rid of it. So this would be the command on the mainnet. If I hit enter right now, it'll say we don't have any balance. And of course that's true. We only have Testnet TAO. If you want to do other things with your wallet, like staking maybe, you can do BTCLI W -- help. And of course this is perfect. It tells you everything that you can do. And then if you want help even deeper, you can do BTCLI W, say balance, and then do a help on that particular part. I just took this balance here. And it gives you more information here. So each of these commands has more help within them. You can basically figure out everything on your own with BTCLI -- help. If you run BTCLI -- help, it'll give you, again, more information with some useful stuff like aliases. We've been using BTCLI -- which of course is a alias for wallet. So let's clone the Tensor Alchemy repository onto our local machine and get it running locally. So we're subnet 26. Now, when we were researching, we were using this Axis Dev or maybe Subnet Alpha or whatever, and we were just clicking on this GitHub link. That's probably safe, but this is just a link on the internet on somebody else's website. So I'm not going to use this link to clone my repository. It was fine for research, but let's just be extra secure here. So the best way to be most secure is to find your subnet. Yeah, it was 26. And just go into the pin messages here and scroll down until you see a GitHub link. All right, that was a lot of scrolling halfway through here. They don't usually keep the GitHub link at the top, but whenever you ask in the channel, they'll say, hey, it's in the pin messages, go and look. All right, let's take a look at the miner guide. So in the miner guide here, we've got some miner requirements. You don't necessarily need this to set it up locally. These miner requirements may not be updated very often, so I like to look in other places like the README here. And it doesn't look like there's any requirements there. So we'll just have to go by what it says here. On this subnet, there's actually 3 guides. So virtual environment for Python. Then there's this prerequisites for guides 2 and 3 here. And then guide 2 is PM2 and virtual environment. And guide 3 is PM2 and Conda. I'm most familiar with Python virtual environment, so I'm just going to go with guide 1. If that fails, I'll probably just go to the second guide. So I'm just going to take this command, copy it. I'm just going to follow these directions. As far as folder structure goes, I like to be in my home directory. You can just do CD enter to be in your home directory. If you do pwd, that's print working directory. So we're in home /username. And I'm going to make a directory mkdir git. I already have one here, so it gives me an error. Once that's made, you can cd change directory into it and do an ls-lrt to be able to see what's in here. You can see I already have a few repositories, so we're just going to add another one here with that first command here. So whenever there's a git clone command, that's going to copy all the code from this GitHub link into your computer. So I've just copied and pasted it in here. The time it takes to clone a repository might be highly variable. Some subnets might require you to download a lot more than others. Step 2, install prerequisites. Copy, paste. Step 2 is done. Step 3, create a virtual environment, a venv. Copy, paste. If you're not familiar with virtual environments, it's just a way for Python to make sure that the version is correct when it's running your files. And you can see that you're in one of these virtual environments by this here, the name of the virtual environment in parentheses, being prepended to your command line. So now if I write Python here, it's going to use this particular environment's Python version. Step 4, install requirements into virtual environments. While this is loading, I'll just say that often when you're going through these setups, you're going to run into a snag here and there, and you're going to have to do some Googling. Often, if you can't find the answer, what you'll be able to do is just go into your subnet that you're mining on and search for the error. Take a couple words from the error and paste them in here, because you're probably not the first person to encounter it. And worst case scenario, if you still cannot get it set up, you can ask the subnet owner here for instructions. Unfortunately, this isn't something I can really help with in the course, because each subnet has its own separate repository with different structure. I would not be surprised if later in this course we end up using the search to help us with a miner setup problem. I just realized we're doing the Mainnet guide for miners. May not want to do that. I'm just going to check how it differs from the Testnet miner guide. I guess I just got lucky here. The Testnet guide actually only has the one way to do it, and it's the way that I picked. This is the first subnet where I've seen that has separate documentation between the Mainnet miner guide and the Testnet miner guide. You're actually going to have to read through the documentation, and if you have questions about it, you're going to go in and you're going to ask them in the Discord. I'll also mention that when you ask a question in your subnet, it's very unlikely that a miner will help you. You're competing against these other miners in this subnet. So really, it's just going to be the subnet owner who can help you, and hopefully they've helped somebody else in the past with the same question. Okay, it looks like it finally finished here. And then in the testnet docs, it's going to tell us to use this netuid 25 instead of the mainnet docs that points at 26. Remember, 26 is the UID on the mainnet, but on the testnet we've got 25 here. So I'm just going to copy this, paste it in here. We're going to replace the wallet name here. So I'm going to grab my wallet name. So grabbing my wallet name here, testnet UID 25. The hotkey was default. We didn't rename that. We're running it against the testnet with this port. So we just ran the command to run our miner. The output here will be different for every subnet. So your subnet will very likely not look like this at all. So for mine here, I'm just scanning through looking for a particular message that is going to help me get my bearings as far as are we already mining or not. But of course I can see now that we are an unregistered miner. So it says we are not registered. So it's going to try again in 2 minutes here. Instead, we can cancel that with Control-C. That's fine to have an error there. So now we're going to register the miner on the testnet using our Testnet TAO from our local computer. So just as an exercise here, instead of Googling or searching the Discord for how to register a miner, we're going to just use BTCLI -- help just to give you a feel for how you can navigate this. So none of these have anything to do with mining directly, although I do know that we need our hotkey wallet to be associated with a UID. So let's look at BTCLI wallet -- help. Okay, it wasn't in wallets. Let's look at BTCLI subnets. And there it is, register a wallet to a network. So BTCLI subnets register -- help. Okay, so it wants us to use the NetUID. That will be the subnet ID, so 25. And then -- wallet.name. That's testnet UID underscore 25. -- wallet.hotkey is default. And of course, we do want to specify that we're doing this on the testnet. Otherwise, it'll try to run this command on the mainnet, and you'll find that you'll have no TAO in that mainnet wallet, of course. And then we're just going to hit yes to continue. The registration cost is super low. And then yes again to confirm. Okay, so you can see that it successfully registered the miner. And then we're going to run this command here, btcli winspect with our wallet name, testnet UID 25, and against the testnet. So I ran this command and then realized that the version is an old version of Bittensor or BTCLI. This warning here is due to the virtual environment here. So I'm just going to take this command and run it in a new tab. So now we can confirm that our cold key testnet UID 25 with the hotkey of default is associated with that testnet 25. I'll just show you what it looks like for a wallet that is not associated with a UID. There's just the cold key and the balance. There's no emission, stake, hotkey, or net UID. So now that we're associated with testnet 25, let's go rerun this launch miner command. So we're back in our virtual environment here. We're just confirming that the command looks right, still against testnet UID 25 with the hotkey of default against the testnet subtensor network, net UID 25. That looks right to me. All right, we're getting different output now. Things are loading. Again, I've never seen any of this output before because it's different between all subnets. I'm definitely looking at stuff like these error messages. Depending on how well maintained the public miner code is, some of these errors you can ignore. It says the NVIDIA driver on your system is too old. Please update your GPU driver. Okay, for something like this on my local machine, I may not set it up if my machine is kind of old. I might just jump on to using a cloud machine. And then if I see this error again on that cloud machine, then I'll actually address it. So just reading through this again, it looks here like we're loading a model. So I guess I'll just wait. So quick note on the logs here. Sometimes it'll look like they've stalled. If that's the case, usually you can safely just hit enter, add a few lines, and see progress happening that way. So I can see I'm downloading more. So my miner's download seems to have stalled on me, and I found out that is because my disk was full. So I deleted 7 gigs, and I'm going to restart my miner now and hopefully have enough storage for it to be able to download everything it needs. I'd probably want like 20 gigs or so just to be safe, depending on the subnet. Some subnets aren't going to use more than 100 megs. Others are going to use many gigs. All right, so I'm just going to cancel this miner now. Control C. Actually, yeah, that's completely messed up my computer, not having enough space. It was down to like 13 megabytes left, and now things are just not working properly. So I'm going to restart my computer. So now I've restarted my computer. I think this is a blessing in disguise because I get to show you how to get back into trying to get your miner work. If you just press up a bunch of times, you can come back to the same command here that we had for running our miner. If I hit enter here, it's not going to work. We're not in the right directory. Remember, I went to the Git directory to clone it. So change directory to Git. If I do an ls-lrt here, I find that the repo is actually not in here. So where the heck did it go? So I went back and looked at the documentation here, and it says git clone. This is the command we copied, but then it gives us a target here. So this tilde tensor alchemy. So what that means is it's just in my home directory. So I'm going to do a cd to the home directory, ls-lrt, and there's our tensor alchemy repository. That's not where I wanted to put it, but we'll just deal with that. So now I'm back in the directory. I can run this command again, but it's still not going to work. And the reason for that is that we don't have our virtual env running yet. So to get a virtual environment running, you're going to do this source command. The source command tells your terminal to use that virtual environment. So luckily here in the documentation, it tells us exactly where it put the virtual environment. So we're just going to copy this. If you need to derive it yourself, if you look at this command for creating a virtual environment, it's putting it in here. So tilde for your home directory, virtual envs, tensor alchemy. That's what it has here, tilde virtual envs tensor alchemy. And then you have to add this /bin/activate on it. So we're just going to copy that, put it in here. And now we have our virtual environment running. So now let's try actually running the command for the miner again. Okay, great. So it gave us an error here. It's an end of file error. This is very likely due to the fact that I ran out of space. So I'm just looking at the logs here. It says home, username, .cache, hugging face, and then a whole bunch of gobbledygook there. And then also when I scroll to the bottom here, it's given us the same location here, .cache, hugging face, gobbledygook. So what I'm going to do is just remove this cache. So what's happened is it's downloaded these files. They became messed up because I ran out of space, and now it doesn't know how to recover. So let's just delete these files and then try running the miner again. Hopefully it just downloads everything properly this time. So to do that, I like to look a little bit at the file system before I delete it. So I'm just going to change directory to the .cache hugging face here. ls-lrt hub. So just looking at these files here, all of them were from yesterday when I was setting up the miner. So I feel pretty confident that I can just delete these. So I'm just going to do an rm-rf hub / that will remove the entire directory and not prompt me if I'm sure. So be very sure what you're removing when you run rm-rf, because if you just were to do /, that would actually wipe your computer. So be very, very careful. All right, so now it no longer exists. Let's go back into the Tensor Alchemy repository. And we'll try running our command again for setting up the miner. And now I can see that we're not running into that error anymore, and it's re-downloading stuff. Okay, so it says my NVIDIA driver is too old. Please update your GPU by installing a new version from this URL. So I guess I will try downloading a new NVIDIA driver. So I guess in here I'm just going to look at the dx-diag. So if I hit Windows button, dx-diag, this will tell me a bit more information about my GPU. If I just click on the display here until I find one that says NVIDIA on it, you can see I have a 1650 Ti. So I'm just going to write that in 1650 Ti. That one looks like it is the right one. Windows 10 is what I currently have. Searching. So it gives me the two options here, studio driver and a game ready driver. I'm not sure on the difference on these, so I'll just download the game one, I guess. And download. Okay, it's finished downloading. Kind of looks like a sketchy file here, but it does come from nvidia.com. Sometimes when you're installing stuff like drivers, they'll give you the option to download like the full version or just like the user version. You might want to download the full version or the biggest one. So in this case, I see that there's just a graphics driver and some GeForce experience. Maybe that'll be helpful with making sure that it's connected up to the other code stuff. At least that's what I'm thinking. So I've just restarted my computer after installing the NVIDIA driver. So I'm going to head back to the repo. And I'm going to run the same miner command. I forgot to activate the right Python virtual environment, so I'll do that now. And let's try again. Okay, so I'm just waiting to see a couple more loops to make sure that we're properly mining. In the meantime, I'm just going to do a bit of investigation as to what this log here means, because we've seen it twice and it seems like it's just telling us some information, and it's probably a loop of some sort. So what I'm going to do is I'm going to go into the repository, and then I'm going to do a grep command. Grep searches, it's kind of like a control F for searching throughout the entire repository. So I'm just going to do a grep for incentive here with a star to look at everything within the repository, and then I'm going to add a couple flags. -I looks for our search term here, so incentive, ignoring the case, so it might also find incentive with a lowercase I or all uppercase or something. And then -R also is included to look at all the subdirectories within TensorAlchemy. So we can see here we have a bunch that match in the code base here. So either this one or this one looks similar to our log here. So I'm just going to look at this base file. You can open it up in any editor here. We're not going to actually be editing the code. So to just look at the entire file, we're just going to do a cat command to show the entire file in our terminal here. So this is kind of ugly. We don't have the color context highlighting, but let's just scroll up here anyways. I can see here we have incentive. This is the line that was highlighted by our grep. And if I scroll up a bit higher here, we can see def loop. So that would seem to me to indicate it's the loop function for actually mining. And if you look at this log line here, it says starting miner loop. This is what a regular miner loop might look like. So it's got a while here, so it'll go probably forever until we turn it off. And we can also kind of skim through this. I don't know exactly what it does, but it's checking to see if you're registered here, it looks like. So if your UID is registered on, in this case, the testnet. So it passed this part of the flow and it gave us this output. So that to me seems pretty good. It means that we probably are properly registered on the testnet and we're now mining. So you'll come back to maybe potentially editing this loop in the future. We're not going to be able to cover that in this course because it's unique to every single subnet. So the subnet that you're mining on is not going to be able to be optimized in the same way that the subnet I am mining on. So it looks like we are mining. We're just doing the same log over and over and over again, increasing the steps. So that's it. We have a locally running machine that we have pointed at the testnet. The next step is going to be renting a cloud miner and pointing that again at the testnet. And then the final step, after we get it set up in the cloud, pointing at the testnet, is to take that same machine and point it at the mainnet instead of the testnet. I just realized that some people might not be aware of how to stop this miner. You can just hit the Control and C button to stop your miner. You might have to hit it a couple times. And there we go, we've stopped our miner now. Okay, now that we have the miner set up locally, we're going to look at renting a cloud machine. Before we do that, I'm just looking at the documentation for TensorAlchemy, and I'm looking for like a file in here that will give me specs or requirements. Not this requirements, this will be like Python requirements, but something like specs or requirements or README even. And I'm going to look for what kind of machine we might need to be renting here. So usually the subnet owner puts it in their documentation somewhere. So I'm just going to read these mainnet docs on the miner. Might be in there. There we go, miner requirements. So when we rent a cloud machine, we're going to be looking for these specs here. So I'm going to use Amazon Web Services as my cloud provider. I'll just refer to Amazon Web Services as AWS. So if you don't have an account, that's fine. You can just follow along with me if you like. Okay, so I filled in a bunch of personal information and credit card details, and now it's asking me to choose a plan. I don't think we're going to need anything here, so we're just going to do basic. All right, let's go to the AWS Management Console. All right, so AWS is massive. There's way more services here than we need. So we're just going to stick with EC2. So I just clicked on that button there, but if you want to find it in the future, you go up here to Services, write EC2, and you should be able to find it here. EC2 instances or resources are just cloud machines. So when we're done setting everything up, you'll see this instance is running as one when we have our one miner running. So we're just going to click on Instances here. And then we're going to launch instance. I'm just going to call this our miner to be simple. And then remember we had a bunch of requirements in our documentation here for the miner. So mainnet guide for miners. It has our information here. For most subnets, they're not going to have like a mining guide that is quite this detailed. So you may need to look in the rest of the repository under, say, the README, or there might be a requirements or a specs file to get the cloud machine details that you're going to want. So in this case, we're just looking for the operating system, Ubuntu 20 or 2204. So I'm just going to click Ubuntu here. It says 2404. That's probably fine. The architecture here can impact your miner and your costs, and it also might be something that is required depending on the subnet. Some subnets use libraries and resources that will only run on one of the two architectures. So I'm just going to take a look at the guide to find out whether or not I should use x86 or ARM. So I'm just going to do a Control F for ARM. I don't see anything, or x86. Okay, x86 seems like it is being used, at least in the third guide. So let's just do that then. Okay, so when selecting an instance type, you can either just click on it here and type in the instance you want, but there is a lot to go through. So if you click on Compare Instance Types, this is a bit easier of a grid to consume. If you click on the gear over here, you can add more columns. We're just going to scroll down and add on-demand Linux pricing because we're using Linux. And then we can see the pricing for each of these machines here. Now we're looking for an A6000,
If you type in A6000 in here, you're probably not going to find it. So instead, we're going to just put in A6000 AWS into Google and see what we can find as far as what AWS would suggest. So I found this Reddit thread. The guy is comparing a AWS instance with a home rig. But basically, this is what I'm looking for. I don't really care too much to read what he says, but this cloud machine is comparable to the 4090, which is the required machine for mining on this subnet. So I'm just going to copy this, P3 2x large EC2. So P3 2x large. And this looks about right. It's about $3 an hour. So we're going to select that. By this point, you're probably wondering about profitability. So let's go check that out. If we go to TAO stats. Okay, so notably we can see that the emissions on this subnet have gone down a bit. So if we scroll down here, we can see that these guys are validators, the ones with the shields, and the picks are miners. So all the ones that are validators are going to be making more than the miners. If we organize by daily TAO descending, then we'll scroll down until we see the first miner. So there's this guy here. So he's receiving 0.08 per day. So the best miner on this subnet is receiving 0.08 per day. So the price is about 511. So do 511 times 0.08. So he's receiving about $40 a day. So I'm just going to write that down. So top miner is 40 per day. And we're going to look at our cost of our instance here. So 3.1, say, per hour is so 24 hours in a day times 3.1 is $74 is our cost per day. So obviously you're going to be mining at a loss if you were to choose this machine. Before we look at changing it, let's take a look at the worst miner on the subnet. So here's our top miner at 0.088. It looks like it doesn't go down very fast. This is another way to visualize the miners. So this top miner that we just looked at is right here. It's a fairly gradual descent here. So most of these top miners are probably making in the ballpark of 30 to 40 per day. Let's look at some of these lower ones here because I wouldn't be surprised if that's where we ended up. So scrolling to the very bottom of the third page here, we can see 256 nodes in the subnet. So this is the third page. And these guys are all making 0 TAO. So they've probably got some issue with their setup. So the lowest miner here is making 0.038. And then the next one up is 0.046. And the next one up is 0.05. So it looks like if we find a machine that will run on the subnet, we can get between 0.05 and 0.08 TAO per day. So let's just figure out what 0.05 TAO is. 0.05 times 511. So that's $25. So we're just going to say between 20 and 48 per day is our ballpark. And so we're going to try to reduce this cost. So this P3 2x large, let's look for another instance. P3.2x large. We're going to look for something similar, and we want it to be less than half of the cost. So the first thing I'll do here is look for P3, and just look for the family name of P3. It looks like that's the lowest in P3s, so I'm just going to go and take a shot at looking at what P2s are like. So I think it's possible that this could work because it does have the required memory. So we're going to try this machine. So in order to remotely connect to your cloud machine, you're going to need a key pair. We don't have any here, so we're just going to create a new one. So we're just going to call this our main key pair. And click on this ED25519. And PEM file format is good. Then you can see it's downloaded this .pem file. You'll want to keep that safe because that allows access to whoever has the file to your miner. We'll come back to this. And then we've got the network set up here. So these are mostly settings for security. You'll want to leave this one checked, allow SSH traffic from anywhere. So that will allow you to SSH into the machine from anywhere using this PEM file. SSH is a utility that allows us to connect remotely to our cloud machine. And then for now, we're not going to check anything more here until we're ready to actually connect to the testnet. And then we have some storage options here. Let's check. It doesn't have anything for storage capacity in the documentation here. So I'm just going to put 100 gigabytes. We'll have to pay a little bit more for the 100 gigabytes, but it's pretty negligible. And now we can hit launch instance. I made a brand new account for this so that I get to experience all the pain that you will get to experience as well. So it says to visit this link. I had to do this with my other account as well. So I'm just looking at what we've chosen. We chose 4 vCPUs. So we have a current limit of 0. So it's set to go to the help center here. We're trying to run an instance with 4 vCPU, but we might want one in the future with 8. So I'm just going to request 8. Now it's been a few months since I had to make this request on a different account, but I seem to remember that I had to request something twice. So we're going to request 8 quota value here. It says this instance limit is supposed to be vCPUs. The last time I filled this out, I only put a couple sentences, even though it says 8,000 characters. And then just hit submit. And then we can see that our case is being worked on here. And if I scroll down, we can see that there's an automated message. Okay, so we're back after a few days of back and forth. We now have a new limit value of 8 for our vCPUs. So let's put those to use. We're going to click on instances and then launch instances. We're just going to call it miner. Operating system of Ubuntu is what we needed. Remember, we chose P2X large as our instance type. I was going to mention in this list here, there's some other images. An image is like a copy of an operating system, but we're just going to go with the standard Ubuntu for now. And if there's trouble there, we might take a look at some of these other deep learning ones. So for the key pair, I already have one here. So if you already have one, don't create a new one, just select it. But I'm just going to show you what that looks like here. I believe this ED one is the best encryption to use nowadays, or the simplest to use. I think I had to upgrade from RSA or something like that in the past, so I'm just going to use ED. I'm going to call this main miner pair, and it's going to be a PEM. I'm going to save it. Now it's saved here. We're going to come back to this. For our network settings here, we're just setting up our very first miner, so we're probably just going to create a new group. But we could also go select existing groups. And if you already have one here, just use that. Because it'll contain all of the firewall access stuff that you need. At some point, if you start setting up more than one miner, it's going to be annoying to go through and change all the firewall settings, so it'll be nice to just use the same security group and only have to set it up once. And then for the storage here, I would recommend something like 100 gigabytes. You're going to be downloading models, they might be 20 gigs. Depending on the subnet, you might want more here even. You can usually change the advanced settings once it's already running, so let's just ignore that for now. And we only want one miner right now, and this looks correct. So I'm just going to hit launch instance. So now it's launching. If I click on this here, this is the actual ID of the machine that we are going to be mining from. You can see it's in a pending state, so it's starting up the machine right now. Indeed, we have our P2X large here. And more information, we can scroll there, or we can just click here and look at more information about it. So now that we have a running machine, this is costing us $1 an hour. So let's not leave it on all the time. If you want to pause it, you can go up to instance state and hit stop instance. Or you can just terminate the instance and then just redo the setup like we just did. When you terminate the instance, though, you're not going to have anything that was saved on the machine. So you do this if you want to do like a fresh install. So now we can see that it is running, and now it's doing a status check of initializing. Let's try SSHing into the machine. SSH is a utility that allows you to remotely access your machine in the cloud. So to remotely access the miner, we're going to copy our public IPv4 DNS here. And we're going to write SSH space, and then we're going to paste that DNS in here. And then at the very beginning, we're going to write Ubuntu at. Ubuntu is like the root or administrative user, so you have to put that in front. And if you hit enter now, and you're going to say, yes, I want to connect to this machine, it's going to tell you that the permission is denied. Remember when we were setting up the miner, we had this key pair here. Well, we're going to use this pair to access the miner. So we need to find where this file is. So if I hit the open folder button, what I'm going to do now is just open up another folder within Ubuntu or within WSL, and then we can just drag and drop this to a place where I can easily access it. So to do that, I'm just going to change directory to the home directory by just doing cd. And then I do explorer.exe and a dot. And that is going to open us up a folder in Windows of Ubuntu. So now all we have to do is just drag and drop this main miner pair PEM file into my home directory in Ubuntu. And now if I do an ls-lrt, I can see it here. So now if we press up a couple times, we can get back to our command to SSH into the server. And we're going to do a -i flag and main miner pair.pem. And this is going to be your command to access the machine. So of course now it's going to tell us that the permissions on this main miner pair are to open. So we're going to change those permissions by doing chmod 400 main miner pair. And then we're just going to hit up twice to try SSHing again. And now we have actually SSH'd into the server. So we're actually on this miner machine now when I'm in this window. If you want to get out of your connection to that miner, you press Control D, or let's go back in again, exit. So by default, your IP or IPv4 address, IPv4 DNS, these change every time you restart your miner. So if we go up to instance state here, we can click on it, say stop instance. We're just going to remember this ended with 160 here. And we're turning it off. You can hit the refresh button here. Sometimes it can take a few minutes for the miner or instance to stop. You can click force stop instance if you want here. Typically, I would prefer to just let it stop on its own so it doesn't end up in some weird state. But we'll do a force stop here because we want as much pain as possible for this course. Okay, so now we can see that the instance has indeed stopped. It's lost its IP addresses. So let's just restart it here. Okay, so now it's running and it's got this different number at the end. Remember, it used to be 160, now we're 105. So we don't want the IP to be changing like this. To do that, we're going to scroll down on the left here to Elastic IPs, and then click Allocate Elastic IP Address. And then we'll just use the default settings here and click Allocate. So now we have this static IP that will not change here. So we'll go to Actions and Associate Elastic IP Address. So we're going to take this static IP address and we're going to now tie it to our instance or our miner. So we're just going to click on our miner here. And then we're just going to allow this elastic IP address to be reassociated. We're going to just click the check mark on that just in case we want to upgrade our server later. And then click Associate. And then if we click on this box and scroll down, you can see the associated instance ID. If we click on that, that should bring us to our miner. And there we have it. Our miner is now running on that 115 IP. So we'll just test that it will maintain that IP. So we're just going to do another stop and then restart. Okay, and now we can see that the instance has stopped and it has retained its IP address, so it's not blank anymore. So if we hit start, it's actually going to just use that same IP address and it will be static. All right, now you can see the instance is running and it has again retained that 115 IP address. So now that we have a miner that keeps the same IP address when it's turned off, I'm just going to hit the check mark here and we're going to turn it back on. And then we're going to SSH into the machine and we're going to follow the directions for the miner guide in the docs that we have here. Again, to SSH, we're going to copy this DNS here. And this is the command we had from before. So I'm just going to write ubuntu at with the new DNS. Yes. All right, so now we're on the machine. There's nothing in our home directory, so we're going to make dir git, and we're going to cd into git. And we're going to follow these directions. So first git clone, and we're not going to target it into that directory. We can just remove that and it'll put it locally into this directory. Sudo apt-get, all this stuff. So this is exactly what we did when we ran the miner locally. We got some errors here because it wants Python 3.10. Just going to do tab complete here. Python 3.12 is all we have. So let's just try editing this command to 12 venv. It looks like that worked. I'll just keep that in mind when we run more commands like this one here. It's going to be Python 12 and then the rest. So I can copy that in, 12. I'm just reading this command here. It says to activate it and then go into the directory, but we changed the directory. So I'm just going to run this part manually here. So copy that in, paste. Yeah, we're already on that virtual environment. We're already in the directory, so now we're just going to pip install the requirements. Okay, so after spending an embarrassing amount of time trying to get the NVIDIA drivers installed, I have found that the instance type really does matter. So let's just take a look here. So we're still using our P2 X-Large and copy this DNS. And we're going to SSH onto the machine. If we look up here, we can see the AMI name that we're using. So that image works only on these EC2 instance types. Now remember, we're using a P2 here. It says to activate the pre-built TensorFlow environment, run this. So I'm just going to do that. And it says here, please note the Amazon EC2 P2 instance type is not supported by Deep Learning AMI. So this image shouldn't be running on this instance type. So let's get out and create a new instance. We're going to call this NVIDIA enabled miner. But we're now going to make sure to use these types of EC2 instances. G4ND, DN. G4DN. This one's actually really cheap, half the price. Well, we can use that one to start with and scale up if we need to. And remembering to put 100 gigabytes on it. Now, I can launch here, but probably you'll end up with that same vCPU issue. The reason for that is that the vCPU that is allocated to... I'll just show you my support cases that I've been working on here. So if I go to see all cases, you can see that I increased my EC2 limit twice recently. So if I open both of these, this was for P instances. And the second one I had to do again for G instances. This time I put it at 16. So those were both approved. So now I can create both P and G instance types. So now let's take a look at this NVIDIA enabled one that we just created. We can write this source if we want, but let's just write NVIDIA SMI first. And look at that, we actually get output now, huzzah. If we do this source activate, I'm sure we could just run the NVIDIA SMI again and it should still work. I'm not really sure what this environment is for, but we'll just keep that in mind as we move forward. Maybe we'll have to use it when we're running our miner. Not sure yet. So depending on your subnet that you're mining on, you may or may not need a GPU with the NVIDIA drivers installed. For the particular subnet I've chosen, and for a couple of the subnets I mined on before, I did need to have it installed. But yeah, make sure that you're on the right instance type here. It says here, but it also does say when you're launching an instance. There's so many words on the screen, it's so hard to see them all. But if we write NVIDIA, we're going to click on that image that we're using. And look, it says right here, supported EC2 instances. So now I'm just going to go back and delete the bad miner, as I've aptly called it. So now we just got this one NVIDIA enabled miner. Maybe we'll just rename that as miner. Okay, we're going to take a quick break here. I'm just editing the course now, and I realized I had some parts that are not recorded. So I'm just going to add some context here. So we tried setting up the cloud machine on that P2 instance. That didn't work. We needed to get drivers installed, and the easiest way to do that was just to change the machine type. So now that we have the G4DN or G4ND machine running, the drivers do work. and we'll be pointing it at the testnet here very soon. We'll jump back to the original recording in a bit here. I just wanted to let you know that I forgot to record the part where I do each of these steps on the G4DN machine. So we're just going to start from finishing number 4 and then start on 5 here in the next clip on the new machine. And then of course when that's done, we'll be pointing at the testnet and then we'll switch it over to the mainnet. Okay, it looks like that installed properly. Let's look at launching the miner now. Copy this command, paste it in. Actually, I just realized we haven't put our wallets on this machine yet. So let's just check and make sure BTCLI works first. It does, but we had problems upgrading it before, so let's just not do that for now. Well, once we've got everything set up and working and the miner is operational, what we'll do is we'll take an image of the miner, so that'll save the settings, the whole operating system, everything. And then once we've got that image saved, then we can play around with maybe upgrading to a more recent version of Bittensor. Let's just also make sure that NVIDIA SMI still works. Yep. All right, let's create our wallets. We're going to do BTCLI wallet regen cold key, wallet name testnet UID 25. We're going to enter our mnemonic here. Okay, we're going to do the same thing for the hotkey. So that seems to have worked. Let's just double check. BTCLI W list. And there's our cold key wallet and our hotkey. So now let's try launching the miner. We're going to copy this, paste it in there. We are not pointing at the right directory here, so we're going to do /git, and that looks like the right file. Wallet name, we called it testnet UID 25. Hotkey, we called it default. 25 is the right subnet. This looks correct. Let's try it. So we got past maybe downloading some models or requirements here, and we're on step 0. So we're just going to wait here and see if this increments. Okay, so now it's done a few steps, which makes me reasonably confident that it's working. So now that everything is set up and working, we've got it running on the testnet. We're just going to create a backup image or a backup AMI. So if you click the check here, click Actions, Images. Now you can create an image or create a template from instance. We're just going to create an image. That way it'll be available for us to pick from when we hit launch instances for another miner. We're just going to put a descriptive name here, so Tensor Alchemy Miner working on testnet. And I like to put the date, November 12th. And then we can just hit create image. Now it might mess with your miner to do this while it's running, but let's click on this AMI here. You can click on that, or you can click on AMIs under images here. And this is the one that we're taking now. So we'll just wait until this is completed. All right, so we can now see that the status of the image or AMI that we made is available. So that means it's completed. So you can either use launch instance from AMI up here if you want to use this image, or you can go to instances, hit launch instances, and here under my AMIs, you can find your image that you created. So this is the one that we just created. We can plug that into a different instance type if we want to try out different machines. So now we can get this miner pointed at the mainnet. Okay, so if I do BTCLI W create, it's going to tell me, of course, I don't have BTCLI installed. I was playing around so much with things, I must have uninstalled it somehow. So I went to the documentation here, docs.bittensor.com, install BTCLI. This has changed recently, so it's always good to look here for how to get it installed. I believe I do have it installed. I just wasn't using the right virtual environment. So I'm just going to copy this source activate command, if I can copy it properly. Now BTCLI wlist. Oh, BTCLI wlist. Okay, so it's working. Let's do BTCLI wcreate with a -- wallet name of mainnet UID 26, because the mainnet of the subnet we're mining on is 26, and we're going to go miner 1. Name of the hotkey, we'll just call it default. Okay, so when we are done creating those wallets, the cold key here and the associated hotkey, we're going to make sure that you've got those written down on a piece of paper. You've written it twice, and then you've confirmed that the pieces of paper match what you see on your screen. If you don't know what I'm talking about, you can go back to the video where we set up a testnet wallet, and I show you the process that I do to make sure that I've written down everything properly so that I can always recover from my paper wallet mnemonic. So now that we've got our mainnet cold key and hot key wallets made, we're going to SSH onto the machine. We're going to try BTCLI wlist to see if it works there. It does not. So let's follow the directions for creating BTCLI. This is a repository, so I'm just going to put it in my Git folder. And then pip install dot. All right, let's try BTCLI wlist. That didn't work. Still doesn't like it. So I'm not really sure why that is. So we're going to cd into Tensor Alchemy. And then we're going to do our source. And I believe it was in the home folder VMs Tensor Alchemy. Usually it's bin/activate. There we are. Okay, so this is running the miners environment now. So now let's try BTCLI wlist. And that works. So again, we can look at updating this later. Really, it should be a pretty high priority when you are up and running, but this course is to get you up and running. So we're going to do BTCLI wallet regen cold key with the -- wallet.name of mainnet UID 26 miner 1. And now we're going to do BTCLI wallet regen hotkey with the wallet name as mainnet UID 26 miner 1. So paste that in there. And then the -- wallet.hotkey default. Okay, so let's take a look, see if we regenerated them properly. And there they are. That's the cold key mainnet UID 26 miner 1. And the default is the name of the hotkey associated with it. And then you're going to have to transfer real mainnet TAO to this wallet address so that you can use that to register on the mainnet. So to get TAO onto our mainnet cold key wallet, you can send TAO however you like through any wallet. I'm just going to use the CLI since I already have some on my donations wallet. So BTCLI wlist. Here I have this donations wallet BTCLI W balance. And I could set the wallet name here, so maybe I'll just do that. Wallet name of donations. So I have a free balance of 1.25 TAO. Let's just double check the registration fee. So I'm on TAO stats here, subnet 26. Registration fee has actually gone down. Yeah, it was at 0.4 and it's gone down to 0.1. So we're going to send a little bit more than 0.1 just to cover the fees. Okay, so we're going to do a BTCLI W list just to see our wallets here. And now BTCLI W transfer with -- network Finny, which is the mainnet. So we're going to transfer from the donations wallet to this mainnet UID 26, although you've got to send it the wallet hash here. And the amount of TAO I want to transfer is 0.11. So we're going to do a BTCLI W list just to be able to see our wallets here. Now we're going to do BTCLI W transfer -- network Finny, which is the mainnet. We can put in the destination key here and 0.11. First 0.1 is for the registration fee. The second one is for if there's any other fees. I can't remember. We're sending it from the donations wallet. And now I'll just show you, if you put in your password wrong, it's going to give you wild errors, which have nothing to do with your password here. So if your password is wrong, it's not going to necessarily tell you, at least with this version of BTCLI. Hopefully they fix that. So now I'm going to put in the correct password. Okay, so it says, do you really want to do the transfer? 0.11 from donations to our mainnet UID 26 miner one. That looks all correct for this fee. Yes. Perfect. So now we'll just do a BTCLI W balance. Wallet.name of cold key and network Finny. Okay, so we've transferred our registration fee to the miner now. So now we can register our miner on the mainnet. So we'll do BTCLI subnets register. Net UID, this used to be 25 when we were playing on the testnet. However, we're on the mainnet now, so we're going to do 26. Wallet name is this mainnet UID 26 miner 1. Wallet hotkey is default. And subtensor.network is Finny. The cost to register by recycle is 0.1. That's exactly what we want, so we're just going to hit yes here. All right, so I now remember that I used different passwords for the two different wallets. So be aware that that can happen to you as well. There we go. We're successfully registered on subnet 26 with a UID of 176. So this is our miner ID. So if we go to TAO stats, I'm sure it won't be updated yet, but eventually when we click on Metagraph and we find our UID here, 176, we have punted this guy off of the network. So when TAO stats updates, we're going to see a stake change here. We're going to see the total dollar amount change as well, probably to 0 here. All right, so we refreshed, and so now we can see that we have accumulated $0 worth of TAO so far, and our cold key here, this 5 GAO UO and the 5EC3HG, is exactly what we have here. We are fully registered and ready to get going. So let's log into the miner and start it and point it at the mainnet. Actually, I just want to note here, it doesn't matter from which computer you're paying the registration fee. I registered on my local computer, even though I'm going to be using a cloud miner because I registered the hotkey, and I'm using that hotkey from the miner. Okay, so we've got our miner here running. We're going to SSH into it. Okay, so we're going to get into our subnet's virtual environment or our BTCLI virtual environment so that we can write BTCLI wlist. And then I'm just going to enter the repository for the subnet and then go to the documentation here on the subnet, copy this launch miner from the mainnet command. And then I'm going to fix up the command here. It says Python, and remember we moved the location of the repository to the Git folder, so we're just going to add Git in there. Wallet name, remember we registered this mainnet UID 26miner1. Hotkey had as default. Net UID is 26. Remember when we ran this before, we had it at 25 because it was the testnet. So just make sure your net UID is updated to the mainnet. And then the subtensor network FINI, that is the mainnet. And the rest of the stuff here is options for the miner. Now I see we're getting a bunch of errors here. These 403s, usually that means like forbidden command or authentication problem. I can't remember which. So it's having a couple issues which might be normal. So we're just going to keep an eye out and make sure that this step increments. Okay, it's been a few minutes here. We can see we keep going up 10 steps. So it is running. We could take a look at TAO stats here and maybe refresh to see if there's any differences. So it's now seeing our IP that we're mining from, which is great. It's going to take a bit of time before your daily TAO starts going up and the incentive and emission start going up. But let's scroll through and just see if there's any errors that we have missed. Okay, so we're getting a couple warnings here. It says strongly encourage you to run a local subtensor node whenever possible. We may end up doing this. Okay, so we're going to cancel the miner here. Sometimes you'll have trouble stopping a miner from running. I just use Control C there, but sometimes you have to use Control Z. When you use Control Z or you can't stop it through other means, you can do a PSAWWJX, which shows you all of the running processes, and then pipe grep for something in the command that you're using for your miner. So in this case, I'll just put Python, and I can see the couple processes. I think these are just default processes in Linux that are running in the background, but if my miner is running, we'll see that here. So I'm going to go to a second connection to the same machine just to show you what I'm talking about. So on the left, I'm going to run the miner, and then on the right, we'll do the PS output here. So let's SSH into the same miner here. And start running the miner. And then as that's running here, we can do a PS AWWJX pipe grep Python. And if I just make this big for a second, and you can see that we do in fact have, I guess, these two processes that the miner is running. So if you ever have trouble shutting down a miner, you could go to the AWS console and stop the instance and reboot it. The other option is to use this PS AWWJX pipe grep Python, and then you can do a kill command. So if we do kill -term on this process ID, it's usually either the first or second column that is the process ID that we want to use. That will kill the process here. So we can see that the miner is just chugging along here or waiting for another step. And let's try killing it. And look at that, it killed it on the other screen here. If that doesn't work, you can do a -9. The -9 kills it for sure, but that might leave some random issues on your system because it doesn't quite shut down the process properly. So in that case, you may just want to reboot the instance just in case here. So we can get our miner running, but it is crucial that we have log files for when errors happen. We can actually ask in the Discord, because the subnet owner will ask you for your logs. And if you don't have those, then you can't really get anywhere. I've been a Python developer for over 10 years, and I have a hell of a time figuring out where logs are for code that I didn't write. I don't know why it's so difficult for me. Maybe somebody else out there has it figured out. I know that if we had decided to use a separate guide here like PM2, the PM2 plus venv, that one does have a way. There's a command you can do in PM2 that lets you look at the logs. But we want maximum pain so that you can learn and get past any issues if, say, the subnet that you're mining on doesn't have PM2 or some easy way to access logs. In that case, we're just going to create our own log file with the output of this command. To do that, we're going to write no hup space the command, and then at the very end, we're going to put in this part here. So this greater than sign says, hey, take all the output from this command, put it into output.log, so a file, and then this says take the errors, put them in that same file, and then the last ampersand here tells it to run this process in the background. So when we hit enter here, we're going to see no output. It's just going to tell us, I guess this is the process ID. So now it's running in the background. If I open up another connection to that same machine here, we can do our PS AWWJX grep Python, and we can see the two processes here that it created. So those are running. Now, if we log out of this machine, so Control D or exit, it's going to say, hey, that's still running in the background, but we're closing the connection for you. And then if we run this PS command again, you can now still see that those two processes are running. Quick overview for if you haven't seen PS. So PS gives you one row for each process that is running on your system. There's going to be hundreds of them. That is why we do the pipe grep Python. So what that means is to look at all the processes that are running and then find only the ones that have Python in the command. So we've got 1, 2, 3, 4, and then the actual command itself was returned because the command itself was a process on the machine. So your miner is still running here. You can keep running it to check. And then if I exit here, so I've got no more connections to the miner happening. I'm going to go back in. I'm going to do ps awwjx grep python. And sure enough, it's still running. So now we told it to output to an output.log file. Output.log. And we didn't tell it which directory, so by default it's just going to go into this git TensorAlchemy directory. So let's go into there, git TensorAlchemy ls-lrt, and we can see there's this log file. If you want to look at the entire log file, you can write cat output.log. So let's go back here and look at what we wrote in here. Aha. The error is that we didn't set up our virtual environment first. So let's go back onto the machine. Let's just do another check here that the process died. It didn't die. So we can kill it ourselves by doing kill-term for terminate, and then grab the second column, I believe. Should kill it, and we'll run that ps command again. That only killed one of them. Let's try killing the other one. Okay, so the miner is shut down now. So let's go back in here. Let's source activate TensorAlchemy. And we're going to just go up to our command here that we made earlier. Copy, paste. And for whatever reason, my terminal doesn't like to copy paste properly, but there we go. All right, so now that's running. We can look at output.log, cat output.log. It's going to show us the entire output of the last run. So when I scroll up here, you can see all the output here from this very last run of the miner. Sometimes you may want to keep more than just the log of the last miner. In fact, I would prefer to have the logs of all the times I've ever run the miner. So I'm going to show you how I'll do that. So we're going to take exactly the same command here, paste it in again, and then this greater than here right before the output, we're just going to put 2 greater thans. 2 greater thans means that we are appending it to output.log. So we're not modifying what's already in output.log. We're only adding new log lines to it. If we only have 1 greater than, then it's going to overwrite the file every time you run the miner. So I like to have this double greater than, and we're running it now. I'm going to log off the machine, log off from the machine in every terminal window that I have. We're going to go back into the machine, just checking that there's nothing connected to my computer anymore, that it's running by itself in the cloud. And if we do a cat on output.log again, we can now see that it's going to have started again right here. Remember, this was our first line error. So it ran the first time here, and then I added that append double greater than part of the command. And so now it's just appending to this file that we created. So that's all nice and dandy. It's a lot to scroll through. I'm not sure you want to do a cat output.log every time that you want to look at your logs. I'll show you a couple ways that you can look at it instead. You can do a less with your file name.
And then in here, the commands are a little bit silly. They're Vim commands, but I can walk you through just a few just to let you scroll around in here. If you do a Shift G, so a capital G, that brings you down to the very bottom, most recent line of the file. You can keep doing a capital G here to check for more new lines. If you do 2 lowercase g's in a row, that brings you up to the top. So capital G brings us down to the bottom of the file. And then if you want to scroll around in the file, you can do B for back. So I'm going a page back at a time. And you can do F for forward, for going a page forward at a time. If you want to go up a little bit less quickly, you can do U for up. So now I'm going up a half a page, and then D for down a half a page. And then Q to get out. So you can scroll around your logs using less if you want. And then the other way to look at your logs is if you do a tail-F output log. This is going to look at the last few lines of your output and display them live. So now we're just looking at whatever the live output of the miner is. So it's just going to add more lines here. Right now there's not much going on, but that next step is going to show up here. We can get out of this by doing a Control-C. I think we can also add a -N for the number of lines that we get to start with. So I think if we do, so -N20 will show you 20 lines to start with. Let's just bump it up to 50 so you can see what I mean here. So yeah, it's given us the last 50 lines of the log file, and it is live waiting for another line, and it will display it when it comes in. So Control-C to get out of this. So the miner is up and running. It doesn't need me to stay logged into the machine. We have a log file that we can look at. We'll just take a quick look at TAO stats here. I don't expect it to be updated yet. Usually it takes a few hours at the minimum to start showing other numbers here. And when we start seeing those other numbers, then we know that our miner is for sure working. And then maybe after this has run for a bit, we can look at optimizing the machine. Maybe it does need an upgrade, because remember, we're only paying 30 cents an hour. Okay, so it's been about 12 hours since we started our miner, maybe 11 or 12 hours. After about 6 hours, I would hope to maybe start seeing some emissions. After 12 hours or a day, we should be seeing some sort of emissions if there's no problem with our miner. So first, let's SSH into the machine and check on the miner, see if it's still running. So we can do this tail-N -50 to look at the last 50 rows of our log file here. This get TensorAlchemy output.log. So we can see that we're up to step 655, so it's chugging along. I did a quick look through the whole log and I could not see any errors. So that's positive. We're still getting this 403 forbidden response from this endpoint. If I just take this word here, Loki, I'm just going to plug it in to the Discord. To search within our specific subnet, I'm going to find the in channel here, and I've written alchemy as a search, but I'm going to want to click this, and now we're only searching within our particular subnet's Discord, and I'm going to look for Loki. And somebody has asked something. This is exactly the same log line as we're getting. He's just saying it's a part of the new log system. It doesn't look like there's any more information other than that. This guy didn't follow up, it looks like, so maybe it means nothing. So let's go to the TAO stats for our subnet and scroll down, make sure we've clicked on metagraph, and we're just going to search the metagraph or the list of miners and all their information for our miner. So we can do that by doing BTCLI list and finding out one of our miner keys, doesn't matter which one. Copy that one, paste it in, and we can see we've got UID 176, that's us.
And we have received no emissions, no incentive, nothing. If it's been more than a day, I'm going to be very concerned, and I'm going to be asking the owner about, hey, what's going on here? What am I doing wrong? But in this case, one thing that I realized we haven't set up yet for our miner is a subtensor. So if you look at the docs here under subtensor, subtensors are like a node that synchronizes with the Bittensor network, and you can run that on the miner. We're just going to run a light node on our miner, and that will allow us to have better connectivity with Bittensor. It is usually recommended that you be running one of these for most subnets. I'm not sure why they use the word recommended, because I found that it always works better when you have a subtensor running, but maybe you don't for your particular subnet. I'm not really sure. Regardless, we're going to set it up and get it running on the miner. I think we're just going to use Docker. It's a much simpler install. Looks like about 6 steps and then some commands here that you could run. You could build it from source, but then you're going to run into a lot of random issues where you got to Google on stuff. So we're just going to get Docker installed and then install it using Docker. So I'm just going to click on this link to go to the official docs. We want to install it for Linux. At the bottom of the page here, I see install on Ubuntu. And this is what we're looking for. We want to try to just get it installed using a sudo apt-get command. Here it says the first step is to set up Docker's package repository. See step 1 of this guy. So let's just follow along here. We'll copy paste each of these into our miner. All right, it says to install the latest Docker packages using this command. To verify the installation was successful by doing a hello world image run. Wasn't able to find it, then it pulled it. Download new version, hello. This message shows that your installation appears to be working correctly. So I think that sets up Docker. Let's now clone this repository for subtensor. So we'll do that in our Git directory. Let's just take a look at the directories we've cloned so far. We got BTCLI, we got our subnet, and now we have a subtensor repository. Go into it and then switch to the main branch in Git. Probably don't even need to do that part. And again, you don't need to do a git pull because you just downloaded it. And then it says here to stop and clean the Docker environment. Again, this is if you're running Docker already. I just want to restart our instance. So this will shut off the miner and reboot the machine. So we're just going to SSH into the machine here. We're going to go into the subtensor directory. We're going to run a light node on the main chains. We're going to use this command. So that's created the light node. And then we're going to enable our virtual environment for the subnet that we're on, so Tensor Alchemy. And we're going to go to the Tensor Alchemy directory now. And we're going to run our miner command here with a double greater than so that we're appending to output.log. And then we're going to change this part here, subtensor network, from FINI, which is the mainnet, to local. And the way this works is instead of talking to Bittensor's mainnet, which may not get back to you very quickly, you're going to talk to your local node, the one that we just set up here, and that should make your miner run a bit more smoothly than relying on other nodes in the network. So we'll do a tail-f output.log to see if it's running. So I'm just going to do a less on the output file. I'm going to scroll to the bottom, and then if you do a question mark, that is like a reverse search. So I'm going to reverse search for subtensor. So you can see here that the most recent run is using this subtensor local network with this chain endpoint. So this chain endpoint is going to actually be the same as the mainnet. So if I hit N here, it's going to do another search, reverse search for subtensor, the next most recent usage of the word subtensor in the log file. And we hit N a few times there, and now we can see this was the run that we were doing before. It was pointing at the Finney network, so not the local subtensor that we had, but again, it's pointing at the same place. And then if we go down a bit, we can see for this run from before, when we were still pointing at the Finney network and not our own local subtensor, we were getting these errors or these warnings saying, hey, you should be running a local subtensor node whenever possible. So we're not getting these warnings anymore. This is right after this SAS dashboard. So what I'll do is I'll do a search for that. To do a search forward, you just do a / down here. I think that's a / and then paste in your word that you're looking for. Oh, so it found that one that we were just looking at, and then we hit N for the next one. And now we no longer see those warnings, and we're no longer looking at a node on the Finney network. We're using our own local subtensor node. It should also be a lot more reliable. So I'm going to let this run, let the miner run for a bit here. We can see we're up to step 5. Everything's looking good. I'll come back to this in a few hours. All right, so now we're back, and we can see that we still have 0 emissions. Looking at our miner here, and I've now realized that there is something that we have neglected. It is opening our ports. So you can see here our miner has this axon, and axon is kind of like the entryway to your miner. So a validator will like use this in order to contact your miner. So if we copy this axon and try to contact it through our browser, nothing's happening. If we go back and we look at all miners and find a different miner that is receiving emissions and contact their axon, you'll see that it actually gives us a reply immediately. So this to me indicates that we can reach this other miner, but we cannot reach our miner. And then just one more note on contacting these axons or IPs and ports is that some miners may set up a whitelist so that only validators can hit their IP. I think that'll probably become more and more common as Bittensor grows. But for now, at least, we can hit these IPs and see what we should be returning here. And then the other thing to note before we go and open our ports is that the subtensor node requirements here have port settings. So we're going to make sure to open this port here, this 8101, plus what it says to do in the subtensor port settings here. So to do that, let's go into AWS and we'll go to security groups. Right here you can see all the security groups we have. We probably have way too many that we're not using because we're just using the default settings when we were setting up miners. But if we go back to our instance here, we can see, if we go to the security tab, we can see the security group that it's running under and a little bit of the settings. So we can just click on this. It'll bring us to the security group within the security groups tab here, EC2 security groups. So this shows that there's only one rule for inbound. meaning that it's only going to answer requests from this port range of 22. That's for SSHing. So the only reason we've been able to reach the machine is because it allows SSHing, and that's it. And then for the outbound rules here, we can see it allows all traffic outbound, which is pretty normal. If we really wanted to, we could close this up a bit, but really we're going to focus on the inbound rules. So to do that, we're going to create a new security group. We're going to allow all traffic for outbound rules. And for inbound rules, we're going to add everything that we need. So we want to be able to SSH into the machine. So that's port range 22. And then we want that special 8101 port. Another way to find that out is if you go onto the machine, take a look at the output, and then do a question mark for reverse search and type the word port. You can see it's serving Axon on port 8101. And if we go back a few more times, it looks like that's the only port that we need open for the miner. So we're going to take this 8101 and put it in here as a custom TCP. And then we're going to look at the subtensor docs here. It says this WebSocket 1 needs to be firewalled off from the internet, from the public internet domain. So we're not going to turn that one on. This port should be opened, but it is not used, so we need to open this one. P2P socket. This port should accept connections from other subtensor nodes on the internet. Make sure your firewall allows incoming traffic to this port. So we're going to add that one as well. We assume that your default outgoing traffic policy is accept. If not, make sure that outbound traffic on port 30333 is allowed. I've never had to worry about this myself, so we're going to make that same assumption. All right, we're going to name our security group here. We're going to name it our Tensor Alchemy Miner Security Group. And then just create the security group. I guess it wants us to add a description here. Allows access to only what is required for my miners on Tensor Alchemy. These are all just going to be 00000s. So then we're going to select our miner here, hit Actions, Security, change security groups. Yeah, that looks right. And we can remove the existing group, add, and there we go. Save. So now we can check whether or not the IP has been opened. We're just going to try hitting this same Axon again. And there we go. We are receiving the same response as a miner who is receiving emissions on the network. So because we opened up these ports that were required for subtensor as well, I'm going to reboot the entire machine and restart subtensor and then the miner code afterwards, because maybe they didn't initialize properly due to these ports being off when they started. So I'm just going to do the easy way, reboot instance. All right, we're going to try SSHing back in. We'll do a ps awjx grep for Python again just to see. Okay, nothing's running. Remember, we go into git subtensor first. And then I'm just going to hit up until I find the subtensor command. There it is, the subtensor command. It's running successfully. So now we're going to turn on our virtual env, get into the Tensor Alchemy repository directory, and then just double check that we've got the right command here. We've got the port here. We've got it using the subtensor network of our local subtensor, which is running now, so we're good to go on that. And then we've got this double greater than sign, putting the output into output.log. And then we've got this double greater than sign, putting the output into output.log. So now we'll just do a tail-f on output.log. So now that we've opened up the ports on our miner and associated that miner with this new security group, the Tensor Alchemy miner security group that we just made, if we click on the monitoring tab and click on, say, 1 day, we can see here that there was not very much CPU utilization for the last 24 hours. And there wasn't very much network in or network out traffic until we opened the ports. So this moment here was when we opened the ports, and we can see a lot of traffic is happening right now. A lot of CPU is being used. So this is a good sign that the miner is actually doing something. If you want to check maybe your uptime for the week, you could hit 1 week here. Maybe your miner crashed for a day and you didn't deal with it right away. So you can see some like network out dips or CPU utilization dips or empty spots like right here. These graphs are pretty rudimentary, but they do give you a really good feel for how good your miner's doing. Okay, so now I'm returning after it's been many months. You're not going to see the same output as I was seeing back when I recorded this course. But in order to see the emissions that you'll be getting, you'll want to do a BTCLI W inspect. You should be able to see it in one of these columns. And I think also BTCLI W overview was also very helpful. As for the miner that we were setting up, we did get it properly connected, fully properly connected to the network. However, we were not competitive at all. And I'll show you the trail. So I went to the Subnet Discord here and started reading through. It's really important to read through the more recent, at least in the last couple months, messages on the Discord of the subnet that you'll be mining on. Because in here, there were some messages saying, hey, I'm having difficulty getting incentives. And there were responses saying, you cannot just use the default miner. You've got to do something more. This is a subnet that is already very difficult to compete in. I had mentioned here, hey, I put in a ticket. Would you mind taking a look? There isn't really a ticket system within Discord, but this particular subnet did have their own Discord and their own way to create tickets. So I joined their Discord, and actually I already have it on the ticket here that I opened up. Just asking them a question of like, hey, it's been a while. Can you help me out? And I ended up not getting back to them quickly enough, and I was deregistered. And they asked, hey, were you using the stock miner? It's not very competitive compared to the models miners are running on the network. So I had tried using some fine-tuned models from Hugging Face that I thought would work. I'm not a fine-tuner at all, so I was just trying things out. But yeah, he says the miners on the network have been fine-tuning for a while, so it's pretty challenging. And like I said, this was actually all publicly available in their Discord. I just needed to have scrolled through the messages. And I should have done that right at the very beginning when I was researching subnets. So hopefully you've learned from my mistake, and hopefully you've learned something about how to set up a miner, because like I said, we did have a fully operating miner on the subnet, with all of our ports open, the subtensor running, everything was running correctly. but it was so competitive that we had to be one of those miners that goes into the code and improves things or is good at fine tuning, etc., etc. So yeah, if you made it this far, thanks for watching. Just know that it took me over 100 hours to do all the editing for this. Usually you can get a miner set up in an hour if you've done it before, but this took a lot of work and nobody's paying me to do it. It's just been a huge time sink for me. And I really hope that making this free for the community helps out a lot of people. And good luck with getting your mining operation running. And I think if you've made it this far, you have all the tools you need to get started. And like I say, you might have to mine on 1 or 2 subnets before you actually find one that you can actually churn out a bit of income from. Again, good luck.